you see metronidazole, sulfonamide, including the sulfamethoxazole drugs. So these two we really largely study in our lab, how to degrade it, how to remove from the liquid phases, and tetracycline is the another variety we really do it. But if you see the worldwide antibiotic usage, right, in the past scenario, it is 200,000 tons per year is really used worldwide. And the problem with the antibiotics is, the pharmaceutical is, they are really difficult to be removed in the conventional water and wastewater treatment systems. I say conventional water. Usually the scheme will be like I have a sedimentation, coagulation, flocculation, filtration. I do a disinfection and really supply to the consumer. In the wastewater treatment also, similar way, I really go for a biological process using activated sludge process, then go for a secondary settling. I go for a disinfection, either with nitrification, denitrification, or sometimes without nitrification, denitrification. Directly I go for a disinfection, and I can really send it for gardening purpose or some kind of a reuse or disposal purpose. And the other side, estimating the pharmaceutical compounds is really required high cost equipments. Like sometimes you have a LC mass or LC MS, high quality equipment is really required because their levels is really very trace. And if you wanted to remove them, you have to plug in additional units in the treatment systems, which may really increase the cost. Then as per the 10,500 2012, and also even in US EPA, we do not have any standards for the pharmaceutical, but they can produce large amount of problems, right? Some harmful effects. So what kind of harmful effects this can really pose is, one is the antimicrobial resistance in pathogens by HGT medicines, right? Antibiotics. And sometimes it can really reduce the sperm count. Then it can also lead to testicular cancer, right, in humans, endocrine disruption, and toxic aquatics. And they are really bioaccumulate in fish and other plants. It can lead to the cycle there. And the continuous release of multiple pharmaceuticals is a lifelong exposure to aquatics. And if you really consume, again, they are really in the food cycle, and they will also really affect the human health. That is why the risk assessment is one of the very important assessment in 21st century. On the other side, there is a white-backed vulture decline, right? It's a vanishing vulture. It's correlated to the diclofenac consumption, which I'll show in the later slide. And one of the cases, the fathead minnows fish, the change of female to male fish is also really possible because of 17 beta estradiol consumption. This is one of the antibiotics which is really used in the human pharma. Then coming to the problem with antibiotics, we have the vanishing vultures, right? So it's a short story because, like, in the one of the communities, right, open feeding of the dead bodies is also a practice, right? So it is meaning that, like, we give the body to the birds and other population to eat. Usually the vultures will really eat that, and they can really grow. It is one way of following a custom in some societies, right? So, for example, like if you wanted to avoid the decay of bodies, you use the diclofenac, a medicine which can be applied as an ointment and to protect it, because now most of the relatives are in the abroad and they wanted to really come back to see attend the last rituals. So we wanted to protect the body from decay. You really apply this particular pharmaceutical drug. So this pharmaceutical drug is also really very poisonous, right? So this vultures eating this particular body, they can really, produce this diclofenac really produces kidney disease, and it can really lead to the death of this particular vultures. So this is a popular article. If you get some time, you can really read through the vanishing vultures. Then you can understand how the antibiotic problem is really penetrating from human to the particular birds. Right. On the other side, we have the cosmetics, right? In India, we produce large of drugs and cosmetics, and we have a rule for this, Drugs and Cosmetic Acts 1940 and 1945. which really controls all this production and different kind of cosmetics which is really used. And the cosmetics, we have a definite definition. Cosmetics as article intended to be rubbed, poured, sprinkled, or sprayed on, or introduced into, or otherwise applied to the human body for serving all these purposes. Right? For example, for cleansing, beautifying, or promoting attractiveness, or altering the appearance, and articles intended for use as a component of any such articles, except that such term shall not include soap. Right? Except then this one, then other things are really defined here. So mainly for cleansing, beautification, protecting attractiveness, and all the things are there. So we have a central drug standard control organization. It's called as CDSCO, which really does all these jobs, right? Approving the new drug for the drug which is coming from different countries, licensing and approving of blood banks, right? So creating various act and rules, banning of the drugs, right? Total license for production and export, testing of new drugs, all the things are really done by the CDSCO. Right, so there is a rule for this. The cosmetic rules 2020 is also into usage now. Then what makes the personal care products? Right, there are 7 compounds grouped under the personal care products. Right, somebody wanted to do a research on this, they can also do on personal care products, how they are really coming into the water environment, what technologies can be really removed, whether membrane technology can also be removed for PCBs. So what are all these PCBs? Starting from body care, you have a hair care, sun care, skin care, the oral care, decorative cosmetics, and perfumes. These are all the 7 things composing the personal care products. Right. Again, if you see here, all these 7 things are really listed here: sun care, oral care, skin, body, perfume, decorative cosmetics, and hair care. So for example, if you take a hair care, shampoos, lotions, hair colorants, all these different classifications are really bubbled here to identify what belongs to which category. So these are all the type of PCBs listed in one particular schematic diagram. You can also look into the Cosmetics Europe webpage, from where I have really taken this particular figure. And one interesting fact you can really observe is, right, so you have list of products which is really, and it is not that women are really using this particular product. Equally, men are also really using. This is only the European database which I really collected. Frequency of use, this is the number of times per day. You can see here, toothpaste equally used. It's a daily routine. Shower gels, much quantity is used, slightly increased quantity by adult women, lesser quantity by men. All the things are really used here. So we would say that it is personal care products are not only belong to women, it is also really used for women. So this is an European statistics. I wanted to check what is the statistics for an Indian context. I wanted to just analyze this average number of beauty and pharmaceutical compounds, personal care products purchased across in India 2022. It is interesting that you have the skincare products, which is really mostly used by female population more than outcompeting the male population. But whereas the hair care products are really more used by the male population. So I would say that based on this particular statistics, females are really interested in their skincare, but the male population is more interested in their hair care products. So when we really use this large number of compounds, usually they will penetrate into the environment there. So what kind of PCB compounds are really termed under emerging contaminants? These are all the 11 PCB compounds which is termed under this emerging contaminants. And you can do a research on this, how much they are really used and how it can be really treated, what is can be its side effects. So most of the chemicals of PCB act as endocrine disturbing compounds, especially like this bisphenols, ethanolamides, TCS, phthalates, and parabens. And you know that emerging EDCs are really potential carcinogens, right? They can produce cancer. and disrupt the metabolism include diabetes, obesity, and even infertility. These are all the three major things which is done through your personal care products. The excessive usage of this can really induce diabetes, obesity, and even the infertility, because you can see that diabetic treatment patients and obesity patients and infertility patients are really very, very large in number. One reason could be because of the usage of personal care products. Right. So how do they pharmaceutical and personal care products penetrate into the environment? Usually as a consumer, we'll use it. Then we excrete or throw it to a waste, and it can really, come into the wastewater. From the wastewater, it leads and end up in wastewater treatment units. And from the treatment units, whether it can be centralized treatment unit, like a common domestic wastewater treatment plant, or maybe like a decentralized small treatment plants. So from the centralized, DOC removal, that is dissolved organic carbon removal, is mainly by biological process. And biological process of conventional nature poorly removes it. Rather, it is really absorbed in the sludge. That sludge will lead to the contamination of pharmaceutical and personal care products. And some of the unremoved pollutants can really pass through the effluent. And from this effluent, it can really reach through surface waters. Then from the sludge, it can go into the agricultural fields, and it can really come back into the ecosystem. Then in the decentralized unit, similar way, the removal by biological process, poor removal, which can really move into the soil if the wastewater is really used for gardening and other purposes. Then from the surface water, also it can really penetrate to the soil. From the soil, it can really end up in groundwater. From groundwater, then again the water is really pumped to the consumer. In the other side, the PCB compounds in the ecosystem from plants and other things, it can really reach the consumer there. So now if you see the problem, right, we wanted to apply the membrane technology where we can really apply it, which can be really applied for water purification, whether the water may be from a surface water or it is really from a groundwater. We really do research on this. And the other side, the tertiary treatment, which can be really applied after the biological process, right? Once the biological process is really done with, then you apply a tertiary treatment, where the tertiary treatment, we can really apply the membrane technology to really remove the pollutants. Right. So we just give a glance about water and wastewater treatment technologies and emerging contaminants removal. We look into that. So we all know that the raw wastewater, which pass through three stages: primary treatment, secondary treatment, and tertiary. After passing the tertiary treatment, it is really sent it for the reuse purpose. Right. So in the primary treatment, mostly like it is the simple processes which is really listed into it, starting from screening, grid chambers, plane sedimentation. In the secondary treatment, we usually adopt a biological treatment process. There are a variety of biological treatment process which can be done through aerobic treatment way and the anaerobic treatment way, starting from activated sludge process, sequential SBR, sequential batch reactors, membrane bioreactor. Then even you have the moving bed bioreactors, right? USB reactors, right? Upflow anaerobic filters, right? Trickling filters. All these things are really applied here. Then in the tertiary statement stage, we apply different processes to remove nutrients as well as the trace organic pollutants, right? So in a conventional treatment process, we stop up to secondary treatment and we'll send it for reuse. Whereas in the sustainable treatment units or advanced wastewater treatment plants, we really go through number of treatment stages. After a secondary settling, we adopt nitrogen removal. We adopt phosphorus removal through various techniques by precipitation or maybe like any other treatment, biological sorption. And after that, we adopt trace organics removal for polishing. Then we will go for the disinfection and we'll send it for the reuse. Starting from step 1 to step 8 is really followed in the advanced wastewater treatment plants. So in the other side, if you see what treatment techniques can really go in the tertiary treatment, for example, like you have a secondary effluent, which is passed through a coagulation, flocculation, or sedimentation by filtration, pre-filter kind of stuff. Then it is really passed through a carbon adsorption. Either it may be like a powdered activated carbon or granular activated carbon, GAC or PAC columns will be used for carbon sorption. Then the pollutants which is not removed through the carbon sorption is really done for advanced oxidation process. And sometimes if advanced oxidation process are not there, we can also really use membrane filtration, a technique followed by a small disinfection before sending into the reuse strategy. Now, the emerging pollutant, how it is really removed, we have variety of technologies, right? Starting from advanced oxidation process, termed as AOPs, and we have the membrane technology, starting from ultrafiltration, nanofiltration, reverse osmosis. But trust me, both mostly NF and RO is really used for treating the wastewater containing emerging pollutants. And sometimes we also use adsorption and ion exchange columns for removing them. Sometimes we use the combination for better removal of multiple pollutants. Right. Having said that, this membrane technology is also applied in the water treatment units, right? So this is the filter which I really use in my household. I do not want to name which brand of filter that I really use. So the influent water which is really sent to the filter, I open the filter and see what is the sequence in which the water is really passing through. It is marked in the sequence as 1, 2, number 3 and number 4. So what is this 1 to 4 units? One is a sediment filter, normally a sand kind of stuff, which is really used to precondition this. Then second stage, we have a carbon filter, removing all adsorbing pollutants. Third, we use a UV unit to really disintegrate all the bacteria and other fragments. And the fragmented and other things are really captured in the NF unit, and it is really sent as a storage tank. Small storage tank is really provided in the filter, 10-liter capacity. Then you can really withdraw the water for a drinking purpose. So yeah, researcher, I don't really see it as a wastewater. I don't see it as a water. I see both of them as a sample. The sample, if I wanted to compare a water sample and a wastewater sample coming out from a secondary process, the sequence of treatment which is really followed are really the same. If you see the characteristics, the pollutant concentration is really very high in a secondary effluent, whereas the pollutant concentration is really little smaller in terms of a water sample from a natural groundwater or maybe like a surface water samples. This is the only difference, but the technology that I'm really applying for tertiary treatment as well as the water purification really follow the same sequence. So in that sense, I would tell that the membrane technology can be useful for both wastewater treatment as well as the water treatment. But the water purifier that I really use, I don't have a RO unit. But this filter will also have unit number 5, reverse osmosis membrane. So based on the kind of pollutant that you have, you can really go for your RO unit. If the pollutant is really free from a particular dissolved organics of smaller size, you don't really need to plug in your RO unit. You can really stop with the nanofiltration membrane units itself. Right? Having said this, we just define what is membrane technology. So the membrane technology is to really applied for removing suspended matter as well as dissolved matter based on membrane permeability and molecular weight cutoff from aqueous system. And sometimes they are really selective, sometimes they are really non-selective. So what circumstances I can use the membrane technology for removing suspended matter? The membrane bioreactor is a typical example where your microfiltration membrane is really used for removing your suspended solids. So here the suspended solids is the bacteria. So that removed by means of membrane technology. We have side stream MBRs, submerged MBRs, where it can really remove the requirement of secondary settling tank, where membrane will really remove the biomass. That is the purpose of membrane technology in removing your suspended solids. Now, dissolved solids, as I said before, 0.45 micrometer is the cutoff. All your metal, organics, trace organics, pharmaceutical, personal care compounds fall under the category of dissolved solids. So obviously, membranes of either your UF or NF or RO is really used for your dissolved solids removal. And if you wanted to remove, for example, like I wanted to remove a trivalent ion from a divalent ion. For example, Al3 plus, aluminum, I wanted to remove Al3 plus from a hardness producing calcium and magnesium. This is really selective in nature, right? Sometimes I do not put a selectivity there. I wanted to use a bare membrane based on my pore size. I can non-selectively remove based on my pore size of the particular membrane and the type of or the size of the particle which I wanted to really remove it. So why to improve membranes? Because in my laboratory, we really prepare membranes and we really wanted to improve the membranes. So why we wanted to really improve the membranes? Because the idea is I want to decrease the roughness of the particular membrane surface. Like if you see like a membrane as a paper, the paper will also have undulations. The visible naked eye, you cannot really see it. But whereas if you really observe through your AFM imaging, you can really see how the surface is really peak and valley kind of roughness is really available. If you have a peak and valley kind of surface, the pollutant will really accumulate there and it can really foul very fast. You can ask me what is fouling. We all know that the fouling means the passage of water is really blocked by the pollutants. Whatever may be the pollutant, it may be like a metal, or it may be like an organic, or it may be like an inorganic, or it may be like a biomass, or it may be like an enzyme. Anything will really block the passage of water which is really passing through. That is really termed as fouling. So to reduce the fouling and accumulation of pollutant on the membrane surface, I wanted to really improve the membranes there. So by doing this, I can increase the flux, right? Flux is usually termed as liter of water which is passed through meter square area of a membrane in a given time. Usually you can remember easily as LMH, liter of water passed through meter square area of the membrane in a given time. That is what called as the water flux. And we also wanted to reject the pollutants. So we wanted to improve the membrane there. And we wanted to improve the stability, because cleaning sometimes usually done by an acid or alkali or some kind of chlorine substances. So if you really do the cleaning by using all this, it should not really degrade the surface. For that, I can really want to improve the membranes there. That is the whole purpose. So quickly we see the geometry. There are like hollow fiber membranes, like your straw that you really use it. We can really prepare these hollow fiber membranes. And in the other side, you have a flat sheet modules, like your, as I said before. Right. So now if you see that this is the microfiltration module, MF to UF, NF, RO. If you see the operating pressure in terms of bar, typically MF module operate lesser than 1 bar, whereas if you go for an RO module, it start to operate from 20 bar till to 60 bar, even lower bar also is possible. But typically this is the pressure range operation in a field scale. And if you see the pore size of the membrane, usually microfiltration membranes will have a pore size greater than 0.01 micrometers. This is specifically used in MBR applications where you want to remove the bacteria 0.45 micrometers. Whereas in the RO, if you go, this will be equivalent to 1 nanometer in size, right? Lesser than 1 nanometer is the pore size of the membrane. The particle greater than 1 nanometer